this is video 4 for lesson number 4, structure of atom, and this is the last video for lesson number 4 and for class 9th chemistry also. In the previous video we have discussed the Bohr-Buddy scheme and we also learnt about valency. In this video we will study what is atomic number, what is mass number, what are isotopes and what are isobars. So what do you mean by the term atomic number? Atomic number is the number of units of positive charge on a nucleus which is called the nuclear charge. Means the positive charge which is present, and you know protons are positively charged, so they form the nuclear charge of a atom. And since each proton has one positive charge, the number of positive charge on a nucleus is equal to the number of protons present. Okay, because protons are having positive charge, so each proton will have a positive charge on the nucleus. So it is the number of protons in an atom which determines its atomic number. Thus, if we define atomic number, it is the number of protons present in the nucleus of an atom of an element is known as the atomic number of that element, and it is represented by letter Z. Now, if you see the slide, here it is the atomic model of helium atom. It is having 2 neutrons, 2 protons and 2 electrons. Okay. If we talk about atomic mass number or simply atomic number, it is number of protons. Okay, just now I am telling you about atomic number only. It is equal to the number of protons, that is 2. And if we talk about mass number, now mass, you know that we have discussed, it is composed of all the 3 things, electrons, protons and neutrons. But since the mass of electron is negligible, therefore the real mass of an atom is due to the protons and neutrons present in it. The sum of protons and neutrons present in the nucleus of an atom is called its mass number. The mass number is represented as letter A, and mass number is equal to number of protons plus number of neutrons. And in case if number of protons is not given, it's written atomic number, then it will be mass number is equal to atomic number plus number of neutrons. Okay, now it's clear. Atomic mass number, or simply the mass number, is equal to number of protons plus number of neutrons, and atomic number is equal to number of protons only. One more thing I would like to add here. You know that an atom has same number of electrons and protons, therefore atomic number is also equal to the number of electrons. Okay, Z is equal to E is equal to P, means atomic number is equal to electron number also and number of protons also. Whereas A, that is mass number, it is equal to P plus N, that is number of protons plus number of neutrons. This slide will make you more clear about both the things. Mass number of carbon is 12 because it has 6 neutrons and 6 protons, and atomic number is 6 because it has 6 protons. Same way, atomic number of chlorine is 17 and mass number of chlorine is 35. Okay, so always remember, mass number is represented as A. It is written at the top of the element, and atomic number is equal to number of protons, which is represented by Z, and it is written at the lower end of the element. Okay, I hope this atomic number and mass number is clear to you. Once more I am repeating, atomic number is equal to the total number of protons in the nucleus of any of the atom. It is represented by Z. Okay, All the atoms in a particular element have same number of protons, therefore they have same atomic numbers. Atoms of different elements have different atomic numbers. Mass number, it is the number of protons and neutrons which is combined to give us the mass number. It is represented by letter A. Both protons and neutrons are present. They are together called nucleons. This should also kept in mind. What are nucleons? It is protons plus neutrons. Okay. While the number of protons remains same, but number of neutrons vary, thus atom of same element can have different mass numbers. Let's see how. Isotopes. Isotope is a Greek word where isos means same and topos means place. That is, all the isotope of element belong to the same group and same period in the periodic table. Okay. Atom of the same element which have same number of protons but different number of neutrons inside their nuclei, they are called isotopes. Just now you have studied same atomic number means they are having same number of protons but different mass number. What is different in mass number? That is number of neutrons. Let's see how. These are the three isotopes of hydrogen. In hydrogen 1, you can see it is having 1 electron and 1 proton. In hydrogen 2, that is deuterium, hydrogen 1 is protium. Okay, hydrogen 2 deuterium, it is having 1 electron, 1 proton and 1 neutron. Here the mass number is 2. P plus N, that is 1 proton plus 1 neutron. Hydrogen 3 tritium, it is having 1 proton plus 2 neutron. Mass number is 3. So they all are belonging to the same type of element. They all are isotopes of hydrogen only, but they have different mass number. Differences mass number can be seen because they have difference in the number of neutrons. Okay, hydrogen 1, that is protium, it do not contain any of the neutrons, so it has a mass number 1. Hydrogen 2 deuterium, mass number 2, 1 neutron plus 1 more proton. Tritium having mass number 3 because it is having 2 neutrons and 1 protons. Okay, one more example you can see C12 isotope and C14 isotope. So what is the difference in both the two? In C12, it is having 6 neutrons and 6 protons, that is 12 is the mass number. Whereas in C14, it is having 14 mass number. Why? Because it has 6 protons but the number of neutrons is 8. So always remember the isotopes are of same element but they just have difference in the number of neutrons, thus they form different mass numbers. Now different applications of isotopes are there in the field of medicines. So this list I have given you in the slide. Please go through that. They also have industrial uses in manufacturing of steel, cast iron also. Then they are also used in making fertilizers and all. So at least learn 4-5 uses of isotopes also. Next we come to isobars. Isobars are the atoms of different elements with different number of protons but equal sum of protons and neutrons. Means they have same mass number but difference is there in the number of protons or the atomic numbers. So they are known as isobars. Okay. Isobar is again a Greek word. Isos, I-S-O-S means equal, and boros, B-O-R-O-S, that is weight. So isobars have different physical and chemical properties because they are of different elements. Okay, let's see. Here you are seeing argon atom, potassium and calcium. If we see the atomic number, it is different in all the three. It is 18, 19 and 20 respectively for argon, potassium and calcium. But if we see the mass number, that is the number of protons plus neutrons, it is same, that is 40, 40 and 44 each. So we conclude here that they have same mass numbers but different atomic numbers. Isobars are always of different elements. They cannot be of same element, and thus they have different physical and chemical properties. Now, if we see the difference between isotopes and isobars, first difference should be that they are the atoms of same element. Isobars are elements of atoms of different elements. Same atomic number, isobars have different atomic number. They have different mass number, but isobars have same mass number. Number of protons and electrons are same. Here, the number of protons and electrons are not same in these atoms. Okay, so these are the differences. Learn these differences also. So this slides completes your lesson number 4 and syllabus for class 9th chemistry also. Thank you everyone.